If you like my content, please like, share and subscribe.
Hello everyone and welcome back to my new video. In my last video I have talked about object-oriented programming and what are the key components of object-oriented programming, which is class, methods, attributes and the object. And one fundamental concept of object-oriented programming as well, which is inheritance. So in my today's video, agenda will be to learn about polymorphism, encapsulation and abstraction. So we'll start with encapsulation and abstraction and then we'll get to know about polymorphism. So let's look at the definition of encapsulation and abstraction. So abstraction is the concept of object-oriented programming that shows only essential attributes and hides the unnecessary information from the user basically. Okay, and it also helps in reducing programming complexity and efforts. So let's say you have a music player, okay, and so in the music player you have a button called play, you have a button called pause, right? So if you just press that play or pause button, it will accordingly play the song or pause the song, right? But inside of that music player, lots of thing is happening, right? Lots of electronic thing is going on. But as an user, you don't have to worry about those science, underlying science. You have just a play button and the pause button and you are fine with it. So you can do whatever you want, like playing or pause, everything. It will work as smooth as a music player could have. But the abstraction is basically the music player brand has hidden the complexity, the underlying science, the underlying electronics behind it, and presented you with a very simple play and pause button. That's it. That is called abstraction. On the other hand, the encapsulation is basically is defined as a wrapping of a data and information under a single unit. So the approach of encapsulation is basically to bind the data and the information together, like in a music player. It binds play button, pause button, and other features in the remote into a single unit, you can say. Okay. So this is basically encapsulation. So encapsulation and abstraction goes almost hand in hand. So to know more about encapsulation and abstraction, we need to understand some stuffs that we will be saying in future. That instead of saying we determined what a class knows and does, we say we abstracted the class. Okay. Likewise, instead of saying we designed how the class will accomplish these things, like how the class will use the play button to actually play the songs, what are the underlying science, for that we say we encapsulated them. The music player has like a remote, a battery, and then they have a play button and the pause button and many other stuff that has been combined into a single unit called music player. So it's the encapsulation of stuff, right? Let's say this car. Okay, so this car has basically like pedal of brake, pedal for acceleration, right? It also has engine. So the user, the driver basically would only know about those stuff, that if you hit the brake pedal it will slow the car or it will stop. If you hit the acceleration pedal it will start running fast, right? Or if you change the gear the engine will act accordingly, right? So that has been presented. So those pedals and the engine gearbox has been presented to the driver. So and driver is doing his stuff, but he doesn't know the underlying concepts, right? Underlying concepts of how the brake is actually working, how the brake and the engine is coupled together to make it happen when you are actually pressing the brake, right? So that the user or the driver doesn't need to know. They don't have to know to drive the car, that how the brake is working in the back end or the underlying science of it, right? So that is basically abstraction. So we abstracted the car in such a way that only the necessary thing has been presented to the driver. And encapsulation is basically, so the card is basically encapsulated in a single unit in such a way that everything is tied together. Like a car has a the ORVM, the IRVM, the wheels, the pedals, the boots, right? So these are coupled in a single unit together in such a way that if you are going to buy a car, you are going to get all of this: wheel, engine, ORVM, IRVM, the gearbox, everything together. You don't have to like look for these wheels or these mirrors from other places, right? So this is basically encapsulation. So why we need this encapsulation and abstraction? Because if you think of the world is very a complicated place, right? So to deal with that complexity, we form abstractions basically. So these are the basic concepts of encapsulation and abstraction, and we will also now going to see how in Python how we can implement encapsulation and abstraction. So let's go to the Python Jupyter notebook. Now let's think about the concept of music player class. Okay, so if I'm going to create a music player class, how we can implement this encapsulation and abstraction in a real life, right? So let's create this music player class. So we can just say music player, right? So first we will define our constructor. I hope you remember. So in the constructor we have to pass this self, and while buying this music player we must have to know the brand, right? So we can just say brand. So now I can just add the keep the brand inside the class, right? And I'll have also the songs as an empty list. Okay, so this songs, I'll present this load songs, maybe load songs behavior to the user, and then the user will be able to load their songs according to their need, right? So now we can also have a method called play, right? So this play method is basically to know. So let's say so all the songs that we have inside this music player, that all will be played one by one, right? So I can just say in the enumerate self dot songs basically, and I can say print f string that playing number one song, which is the song itself. Okay, I can do that. And once we're done with all the songs playing, we can just say finished playing. You can just say finished playing, right? Cool. So we have created our first method called play. So now we can have a method called pause, right? So which will just say that the song has been paused. Okay, so now we can say a load songs basically. So according to the user, they can load their songs. So I'll just accept one list which will be given by the user. So, and according to their songs, we'll update the attributes of this music player class, right? Songs basically. Yeah. And now let's say while playing this song, it will always play this song according to the way user provided while loading the songs, right? But user may want to shuffle, right? Shuffle the playlist basically, as we all do. So in that case I can just take a shuffle uh, boolean parameter, let's say. So if user wants to shuffle it or not, so by default it will be false. If user provides, then we can just shuffle it accordingly. So that shuffle is basically, I'll write it here, shuffle self. Okay, and we can just import a random module from Python library. So I'll talk about that library later, but for the time being just understand that we have a random library in Python which will shuffle the lists basically. So I can just say random, and we have a method called shuffle inside random library, and I can say self.songs. Okay, so it will shuffle it. So now while playing the song, if user wants to shuffle it, he or she can provide whether the shuffle attribute should be true or false, right? So if it's true, then we can say if shuffle, then just call that shuffle method, and it will shuffle the songs list basically. So now think about it, that this shuffle method, do we need to expose this to the world? We don't want to do that, right? Because user don't want to know how we are going to shuffle it, right? So for that you can just hide this shuffle information from the outside world. You can do that, right? So the way you can hide this shuffle method is using this underscore underscore attribute. So double underscore basically. So that way you can let the user only know that yes, you can shuffle it, but you don't want to be able to know how we are going to shuffle it basically. So by adding this double underscore, what we let the music player class know that this shuffle class is a private class of this music player. Only inside the music player class you can use this shuffle method, but not from outside. So in that way it is very easy for the user or the end user who is going to hear the songs in this music player. For them it will be very easy to just switch the shuffle. So you can think of this shuffle parameter as a switch. So he or she just switch this shuffle button, and the song will automatically be shuffled, right? So in that case, so now remember the concept of abstraction and encapsulation. So here we did abstract it by saying that just add this shuffle switch and we will shuffle it for you. You don't have to bother about the approach that we have taken. That's it. So we did it now. So now I can just say also that when you are going to buy this music player, you will say that welcome to the family, welcome to the, let's say, Apple family, or the family of let's say brand. Okay, welcome to the brands family. So that we can do. So now I have created this music player class, right? And now I'm going to buy a music player of a brand. So let's say I'll say my music player, my player. Okay, say music player, and I'll say the brand as Sony. So welcome to the Sony family. So I have purchased successfully this music player of Sony. Now what I can do, I can first load my songs, choice of my songs, right? So I can say load songs, and here I can pass the list. So the list will be songs list. So here I can load Vande Mataram. I can load Summer of 69, right? I can load Indino. I can load Hotel California. Okay, so I can load this stuff. So I can just say these songs. So see this, what is this error? This error is basically load songs. So we have not passed self here. So here we have to pass this self basically. And we have successfully loaded songs into my player. Correct? Now if I want to play the songs, so I can just say my player dot play, and I have not passed shuffle yet, so it will automatically be false. So it will say that playing the number 0 song. Okay, so now if we want to shuffle it, so we can say my player dot play, and now I will switch the shuffle to true basically. So yes, because we have to call this shuffle method using this thing, and now so if I say shuffle true, then you will say that it has been shuffled successfully, and music player has played all the songs that we have loaded according to in a different order basically. So this is the concept of abstraction and encapsulation. So in that case, now you can think of this music player class, it is working as a single unit, right? This music player class, and so we have this play, pause, load songs and shuffle methods inside. So this is basically a simple example which I think is very useful in understanding the concepts of encapsulation and abstraction. So now let's look at the definition of polymorphism. So poly means basically many, and morph basically means the form. So many forms you can derive from polymorphism. So it is one of the core concepts of object-oriented programming, and it describes situation in which something occurs in several different forms. Okay. So consider an example that a poker game is getting played, okay, on a table. So where there are like 4 people sitting on that very table, A, B, C, and D. You can think of in this way. So A is basically a professional card player. So B is basically a gunfighter. C is basically an artist, and D is a poker player. You can say, okay. So now one of the player turns to A and asks, "What will it be, partner?" So the partner replies, "Draw." So suddenly everyone goes wild. The artist who was sitting across the table from A suddenly pulls out a pad of paper and a pencil and starts drawing. The professional card player who was sitting across A, ready to play, draw poker. And the gunfighter to his left goes for his guns. So this always happens whenever I say draw. Fish polymorphism. Thinks A to himself. So you can learn several interesting stuff from this experience. First, the polymorphism is in the way the dealer interacts with the players. The dealer did not care what type of player, what type of people we had at the table, right? He treated them all the same way. Even though the message draw meant one thing to an artist, one thing to the poker player, and yet another thing to a gunslinger. So as far as the dealer is concerned, player A, they are only people. So polymorphism in the concept that permits this to happen basically. So it's a form in a many way. So this draw is, you can think of this draw as a behavior, and it can be the same draw can be implemented in a different way in a different objects, a different class. So here we have an artist class, we have a gunfighter class, and we have a poker player class, right? So these 3 class has implemented this draw behavior in 3 different way, but the name remains same, right? That is what we call a polymorphism. So now let's look at the polymorphism in a way, in a programmatic way, how you can implement polymorphism in Python or in your future project or something. So this music player, if you are designing this music player, it has a button called play, right? If you create another class called video player, that will also have a button called play, right? So this play is acting differently in different class. So this is basically polymorphism. But the most intuitive way to implement a polymorphism is to when you are using the inheritance. So as I told you in my last class, that inheritance is basically when you have a common feature, like that the way I told you that this person class has a common feature of height, weight. So that common feature should not be in every different child class, right? So it should be in the main class, that is the parent class or the base class. And then only the specific stuff of the child class can be implemented, can be added to the respective child classes. So in terms of inheritance, it's very intuitive to use this polymorphism. So let's say we have a class called animal. Okay, so this animal has an constructor. So let's say what are the common properties of animal. So let's say the height of an animal, the color of an animal. Okay, so we can just initialize those inside the animal class, and we can have a method called about to fetch the details of the animal, of that particular animal, when we're going to create it, right? So we can just say here below the animal details, say, and then you can say print height is basically the height, and the color will be basically the color of which has been given while creating the animal object, right? And this animal can have a behavior called run as well, right? So most of the animals can run, so we can just say that almost all the animals can run, right? So I've created this animal class. Now suppose I want to create a class called tiger, which obviously has height and color, right? So I don't want to use the same attributes in the tiger class. So since I have already animal class created, so I'll just inherit the animal properties inside my tiger class, inside my child class, right? So right, so now if I initialize this method, this tiger class, so I can just say that obviously with height and color I can have, maybe say, how aggressive this animal, this tiger is, right? I can have that. So remember, in our last class, in the inheritance class, we saw that we can call the initialize method, that is the constructor of the base class, using this name of the class, right? That is person dot init we have called, right? We have called this constructor method using that person class. Just for your reference, here we have called this person.init, right? So when you are calling this constructor method of the base class using the class name, you have to pass this self. But there is another way you can call the constructor of the base class, that is using the concept of super. So that super is basically, super is the keyword. So that is basically you can use to call the method of the constructor of the animal class. So you can just say the init. So the thing is, here if you use this super, you don't have to pass the self. That's the difference between calling the constructor of the base class using the class name or using the super, because super is always take the first argument as self, so you don't have to specify explicitly. So you can just specify height, color, that's it, and you can add the aggressiveness of this tiger and keep it in your tiger class. Okay, now so now you can have a run method, the behavior run also in the tiger, right? But so this run can be different for different animals, right? So though it has the same property, but the way a tiger runs is definitely different from the way a cow runs, right? Because though it has the same property, but the speed, but the duration, or the area that a tiger covers in 5 minutes, a cow will never be able to cover that. So that is basically polymorphism. That so we have a base class called animal and which has a basic property of run, but it can be different in child classes, right? So here we can redefine this run method in the tiger class and say that tiger runs fastest. Tiger runs very fast, probably fastest among all the animals, right? So that is it. So this run method we have in the animal class, but since we have some slightly different technique tiger actually applies while running, so we can define this run method in the child class. So that is the most intuitive way of using the polymorphism. So now if I try to create an animal with height of around 100 feet and maybe color as yellow, so I can create that. I can also see about that particular animal. So here it will be about is y about is, so because we have to do this comma instead of, so about this animal, with this animal height is 100 feet and color yellow. But now if I am going to create a tiger, so let's say I'll provide this tiger height will be, let's say 30 feet or say 10 feet, okay, and it will be like yellow and white, and let's say it is aggressive, so I'll pass true. Okay, so now if you want to see how a tiger can run, it says a tiger runs very fast, probably fastest among all the animals. So it's a very fine way of implementing polymorphism. So you can think of another example which we will be coming across when we're going to implement machine learning. So in machine learning, so there are like lots of algorithm to predict the future, basically you can say. So for all machine learning algorithms, you have to train the algorithm beforehand to be able to use that model as a predictor. So to train that model, you have to use the fit method. So this fit method has been implemented in all the machine learning algorithm. So it is doing the same thing, but it is accepting different parameters, and for different type of algorithm, it has a different way of writing the logic inside. So this is a very subtle way of implementing polymorphism in a object oriented stuff. So I hope you understand the concepts of polymorphism, abstraction and encapsulation. Please let me know in the comments below that if you have any doubt on the topics. Thank you guys. In my next video, I'll be talking about some very interesting concepts and I'll be going to explore the world of machine learning. So stay tuned. Until then, goodbye. Happy learning.
If you like my content, please like, share and subscribe.